Welcome back, students. Today we will be discussing the topic of relative velocity. The word relative is often used whenever we are making any kind of comparison. Talking about comparison, obviously there should be two physical quantities. What are these two physical quantities? Here we are comparing the velocity. Velocity is the physical quantity and the velocity of one object with respect to the other. So that is what we refer to as relative velocity. So when two objects, suppose I name these objects as A and B. So when two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is called relative velocity of object A with respect to B. Suppose, as you can see right now in the screen, if I name the objects as A and B, then as I was saying that when two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is called relative velocity of object A with respect to B. So what is relative velocity? The relative velocity of one object with respect to another is the velocity with which one object moves with respect to another object. Hence, relative velocity is defined as the time rate of change of relative position of one object with respect to another. Let us analyze the concept of relative velocity by deriving its expression. Consider two objects A and B moving with uniform velocities v1 and v2 along parallel straight tracks in the same direction. Let us consider two objects A and B moving with uniform velocities v1 and v2 along parallel straight tracks in the same direction. Let x01 and x02 be their displacements from the origin at instant t equal to 0. So these are the displacements of the objects A and B respectively at time t equal to 0. If at any time t x1 and x2 are the displacement of the two objects with respect to the origin of the position axis. I repeat, if at any time t x1 and x2 are the displacements of the two objects with respect to the origin of the position axis, then for A we can write down x1 equal to x01 plus v1 t. Let us consider it as equation 1. Similarly, for B, we can write down x2 equal to x02 plus v2 times t. Let us consider this as equation number 2. Subtracting the above equations, subtracting these two equations, what we will get? We will get x2 minus x1 equal to x02 minus x01 plus v2 minus v1 into t. When we subtract these two equations, this is what we get. Let us consider this as equation number 3. Now here x02 minus x01, this can be written as x0, and what is it representing? It is representing initial displacement of object B with respect to A at time t equal to 0. Similarly, we can write down x2 minus x1 equal to x, and this is actually the relative displacement of B with respect to object A at time t. Thus, if we go back to equation number 3, we can write down equation 3 as x equal to x0 plus v2 minus v1 times t, or x minus x0 is equal to v2 minus v1 times t, or x minus x0 divided by t is equal to v2 minus v1. Let us consider this as equation number 4. Here, left hand side of relation 4 gives the time rate of change of position of object B with respect to object A. That is the relative velocity of object B with respect to object A. So, therefore, relative velocity of B with respect to A. Now let us use a notation something like this. VBA, velocity of relative velocity of object B with respect to object A, and that is equal to V2 minus V1. That is velocity of object B minus velocity of object A. Let us consider this as equation number 5. Position time graph in relative velocity. Let us see how graphically we can represent relative velocity. For this, we will be making use of equation number 5. From equation 5, we note that the relative velocity, that is VBA, will be 0, negative or positive depending upon the relative magnitudes of V1 and V2. I repeat, from this equation we note that the relative velocity VBA will be 0, negative or positive depending upon the relative magnitudes of V1 and V2. So now I will be considering different conditions. Let's begin with the first one. If the two objects A and B are moving with same velocity. That is, V1 is equal to V2, or you can say V2 minus V1 is equal to 0. Then what shall we get? We will get x minus x0, that is equal to 0, or we can write down x is equal to x0. That is, the two objects will remain always constant distance apart, which is equal to the relative distance between them initially. Like whatever was the initial position of these two objects, whatever was the distance between these two objects at time t equal to 0, that distance is going to be maintained throughout the journey. Therefore, their position time graphs are parallel straight lines. Their position time graphs will be parallel straight lines. How to represent that? For that, I have to draw the axes. If suppose I am representing position on the y-axis and time on the x-axis, position on y-axis and time on x-axis. If x01 is the position for A and x02 is the position for B, then for object A the graph will be like this, and for object B it will be like this. As I was saying, their position time graphs are parallel straight lines. But how should the graph for relative displacement look like? What should be the graph for relative displacement? Again, for that I need to draw the axis. So the relative displacement, that is x minus x0 with respect to time, that will be a straight line, because x0 is equal to x02 minus x01. The two objects remain a constant distance apart throughout the journey. So this will be the position time graph for relative displacement. Let us go to the second condition. If V2 is greater than V1, that is V2 minus V1 is a positive value, then we will find that x minus x0, that will also be positive, isn't it? It means the relative separation between the two objects will increase by an amount V2 minus V1 after each unit of time. Therefore, their position time graphs will open out gradually. So how will the position time graph look like? For that, again, let us draw the axes. We are marking position and time. So if this is the position, initial position for A, and this is the initial position for B, if For A, we can draw a graph like this. Then for B, the graph will be like this. As I was saying, their position time graphs will open out gradually. Coming to the third condition, if V1 is greater than V2, that is V2 minus V1 is negative. It means that x minus x0 will also be negative. It means the separation between the two objects will go on decreasing by the amount V1 minus V2. It will go on decreasing by the amount V1 minus V2 after each unit of time. So after some time, the two objects will meet, and then the object B, which was to the right of A, will get more and more to the left of A. So the time coordinates corresponding to point of intersection will give their time of meeting, and the corresponding position coordinate gives the position of meeting. So how should the graph look like? We are plotting position in the y-axis, again time on x-axis. This is the origin. This is the starting position for A, and this is the starting position for B. So this will correspond to the position of meeting, and this will correspond to the time of meeting. So from the time axis, we can find out the time at which the two objects will meet, and from the position axis we can figure out the position, corresponding value of position at which the two objects will meet. That is the point of intersection of the graph. So we will end our discussion on relative velocity. At this point, we will be discussing some more concepts regarding relative velocity in our next session. Thank you.